Hello everyone, today I would like to show a demonstration test that is using the KEPServerEX, using this software and the Excel as well as the Siemens S7-1200 controller, using these three together to demonstrate how we can transfer the PLC data to the Excel by DDE function from the KEPServerEX. Totally, I will use two videos to introduce this whole process. So in this video, I will mainly focus on build up the PLC channel between the S7-1200 and this KEPServerEX software. In addition, to make this video, I'm not sponsored by any other companies. Just because recently in my job, one of my customers in their plant, they are using the KEPServerEX software, so I got a chance to look at the detail of this software. Even if I have been knowing this software for a long time, but just haven't got a chance to download this software and do a test. So using this chance, I download this software and use this DDE function and transfer the PLC data to Excel by DDE function. Okay, so firstly, how to download that Kepware software. So you could go to the Kepware.com, this website, and download this free demo. It supplies 2 hours trial lessons, so 2 hours basically is enough for our test. And to download this software, hit this button and you need to fill some your personal information and then download this software. And because our controller that is a S7-1200, so let's demonstrate how we can quickly set up the Siemens S7-1200 project. DDE Excel S7-1200. Okay, so once we created this project, let's shift to project view. In my hand, I have one Siemens S7-1200 controller that is a 1214 version 2.2. So I'm going to add a new device. And I will use this unspecified CPU. And because this controller that is a 2.2 version, I will select this. And this allows us to automatically detect the serial number of this controller. Alright, this hardware area, that is one shell hardware. So let's hit this detect. Click the search. Okay, it searched this controller. Oh, that controller, that is a 1212 AC/DC relay, and the IP address is a 0.10. Make sure your laptop that is the same subnet range here. Detect. And once we hit the detect, the TI portal will upload the hardware configuration to this controller. Okay, so it detects this actual controller. Double click, so we can see this IP address already detected and uploaded. Let's go to the CPU properties and go to the system and the clock memory. Let's enable this. So once we enable this, that means the MB1 will be used for the system. So for example, always on will be M1.2. Especially we will use this area, MB0. For this byte, from 0 to 7, it will be controlled by the CPU internally. It will generate a different pulse here. So we will use this MB0 or MW0. So let's come here and let's create a DB. Add a new block. We will create a global DB. Select this data block. That is a global DB. And let's rename data Excel. And let's rename this number. We name it number 10. So let's demonstrate, maybe in your project, you won't use the number 1, maybe you will use the 10 or 100. that is a DB10 data Excel. And from here, I set up 16 byte. We name the bool from 0 to 15 and create 2 integer, create a 2 real, that is a float, and create a 2 strings here. Currently, if you look at this column, name, date type, start value, retain, something. If you hit this retain, once your CPU got shut down, stop the power, the data won't be lost. But currently, all these tags in the DB, it doesn't have the absolute address. By default, in Siemens S7 1200 or 1500 controller, if you create a tag, by default, they all optimized address. However, if you are using the third-end software to read the data from this PLC or write the data to the PLC, usually those software still use the absolute address to read the tag between the PLC and the software. So we need to activate that absolute address assigned by the system. We need to go to the DB, right-click, select the properties, and decheck this. Disable this optimized block address. Hit OK. So once we hit the OK, better take care of this area. Hit OK. Hit OK. So once we hit that, disable that optimization, so it will create one additional column named offsite. That is the physical address in this DB for different tags. So it haven't assigned the address yet because we haven't got a compile. So we save the project, compile this DB. So once we compile, we can see the detailed address for each tag. For example, for this integer 1, that starts from the byte 2, which means the byte 2 and the byte 3, that is for this integer. And the next integer, that is the byte 4 and 5. The real, each real number, each real tag, this is float, takes 4 bytes. So that's why it starts from 6 and 6, 7, 8, 9. So it takes the 4 bytes. And next one, that starts from 10. Okay. So till here, we finish everything and we go to the OB1. I programmed MW0. We will use this MW0, this word, right into the integer 1 in this DB10. This. So once we program this, let's hit the save and compile and download. The first time we download the hardware and the entire software, the system asks us to stop the system and restart. And once we restart, if you change the data or the program area, you can change on the fly. So download. Finish. And then we start the module. Currently, the CPU is running. If we hit this, online monitoring, this is the actual data is running. The integer 1 is wrote by that MW0. The MW0 come from the properties of this CPU. If you recall, we set this system and block memory. So all those bits are controlled by the controller. So that's why there's a byte 0 and byte 1. They all controlled by the CPU. So just for test, so we use the program write the MW0, which includes MB0 and MB1 right into this integer 1. That's why if we go to the online of this DB, we can see this integer 1 is changing. To write the data into the DB, we can write the data from here, right click, and modify the data from here. Also, we could go to the watch and the force table, add a new table. So we can drag the integer, we can drag the bool 1 and those integer and those data to this watch table here and hit the monitoring. So we can write the data to here. For example, let's write this bool 1 to 1, right? C. And we can write the real number. For example, the first one that is 3.14, next one that is 6.28. And we can also write the string 1 to a string number. For example, A, B, C, D, E, F, G, H, I, J, K, L, M, N. Okay, hit the enter and then hit this modify. The data rolled into this DB. So, see. So we prepare those data for test the Kepware area. So ideally, once we build up the communication, and if we write this data address correctly from the Kepware, we can see this data in the Kepware. So let's shift to the Kepware software. So once we download that KEPServerEX software, you can install. The whole installation process will take roughly 5 to 10 minutes. Once you finish the installation, you can go to this software icon and right click. So I will prefer to run as an administrator. So if this is the first time, the system will give you some test channel or demonstration channel here. I won't delete this. If you want to do some comparison, you can do that. So I will create another 2 new channels here. I will explain why. So firstly, let's set up one connection or channel. That channel is used to communicate with a controller first. So right click, hit the new channel, and let's select what kind of things you need to connect. So we need to connect the Siemens controller, Siemens TCP/IP Ethernet. Click this, and let's rename this channel that is a S7-1200 PLC. And network adapter, keep in mind you select the correct connection you are going to use, because usually our laptop has a wireless and the Ethernet physical connection. So keep in mind, select the correct one. And I will keep those as a default. Okay, make sure we are selecting the correct. We select the Siemens TCP/IP Ethernet. Finish. And we just build up this channel. Let's build up the device connection. Right click, and this is the device connection. So that is our actual controller, that is a S7-1212. And the type of the controller, S7-1200. Next, IP address, that is a 192.168.0.10. Click next. So basically, we will leave this as a default. Next, connect timeout, request a timeout, attempts before timeout, we will leave as a default. But this is a tutorial, you can look at this detail. And keep in mind this port number, that is a 102. By default, the Siemens S7 communication, they are using the 102, this port number. Okay. So keep in mind this, for different kind of a brand CPU, they will use a different way to organize the high byte and the low byte. You could select this help. And for the Siemens style, it will use this big endian this way. And for other brands, sometimes they will use this little endian. So keep in mind that Siemens will do the lower byte at the left. So keep in mind this. Okay, next. Go through the settings, no big problem. And by default, keep in mind this. Maybe sometimes this software cannot organize this slot automatically correctly. So you better double check this. The CPU rack is 0 and the CPU slot that is a 1. That's because if we go back to the Siemens area, if we go to the hardware configuration, double check this CPU that is the number 1. For the i7 1200 and 1500, that slot by default is 1. But for the i7 300, that slot is number 2. And rack number here it shows a 0. Double check this. Okay. So we set up this channel and this device terminal, and then let's create a tag here. Right click, new tag. Let's set up the bool 1. This is the tag name within this KEPServer software. And this address, it needs a syntax. So how we can tap this format? Let's hit this small button. And let's look at this format. You can pick one as an example. For example, for this bool, should be a dbx something. We will use this db1x something, and that is a boolean. So select this, select OK. So we will use this structure or syntax. But actually our db number, that is the db10 if we recall. So we will write this db10. And the bool 1, that address, that is a 0.1. So I will rewrite this 0.1. This is the actual bool address. So I will delete others. And from here, the date type for this bool, that is a boolean. Okay, we will leave this scan rate as 100. Click the OK. And we will test the 2. So let's copy and paste. And the next one, so the next one, that is a x02. 0.2, bool 2. Okay, so next, let's create a one integer. Integer 1, and that address, let's find this. So that is a one word. So db1 integer 0, right? That is a word. That is a word. So click the OK. So that is a db10. Integer, the first integer start from the 2. Okay. Because from the PLC wise, to address this integer, the full address, that is a db10.dbw2. And we will select this word, click OK. And the next integer, that is the dbw4. So if we copy this, and for the second integer, we will write 4. This address depends on the actual address in the DB, the system assigned. So that's the 2 integer. Let's create another 2, real 1. How we can write this address for real? So let's go that. Let's go to real here, float. Click this and db10 real. So first real in the db, that is a 6. Okay, real 6. And we select the float. And the second real, it takes the address to 10 because each real, it takes 4 bytes float. Okay, so we create 2 floats, and then the last we will create 2 string. String, I will create this way. I will show a little bit different. String T1, test 1. So if we look at the string, it has two different ways. One way is here, string. One way is this. So I will show those two different ways. The first way, let's hit this, string byte, which means the byte B here, that is the start byte, the string start. And this N means the length of that string. So it has a tricky here. So let me select this first. I will explain after. So this start from, so our DB, that is a 10. And the byte, the first string from this list, it start from the 14, the byte 14, okay? And the length, by default, I will show, let's say, 8 character. So delete others, and let's select the string. Select the string, click OK. So that is a string 1, test 1. Create another one, and test 2. So we will use another way. If we go down, so this time I will select this, string 00 dot length. Click OK. So it still start from the 14. And this is the length of that character. We select the same 8 length. Our DB, that is a 10. Date type string. Okay. So we use a different way to address this string. Actually, it should show the same data string. Okay. This is the demonstration for that tag test. We can save our project first. Save this project. Okay. So to test those data, we can hook up this quick client. The channel is named the channel i7-1200 PLC and device, that is i7-1212. So, and from here we can see all those data are changing, right? So we can see the rack number, slot number, bool, what the status of that. Bool 1 currently is 1, and the integer, this override by the system MW0. So that's why it's changing. And this is the real number, right? So if we change the number here to 13.2, let's hit OK. So we change the data. If we shift back to here, so we can see the data already changed. Okay, let's look at this string. This string in the DB, we wrote A, B, C, D, E, F, G, H, I, J, K, L, M, N, this length. So if we go back to the Kepware, so we can see the first one, we use the byte 14 and the length, that is 8. So it shows like this. It's a wrong code here. But this, it shows the 8 character, A, B, C, D, E, F, G, H. That I, J, K, because we only said 8, so the left letters won't be shown here. But why this happened here? Right? That's because if we address this string by byte, if you recall for the string, the first byte of this string tag, that is the length of this string, and the left byte, that is the actual letters in this string. So for this, it starts from the byte 14 and the length, that is the 8. So the actual letter that's come from the 16. The byte 14 and the 15, that is the length. So to correct the show here, we can double click change. So actually this string, the letters start from 14, 15, 16. We still show 8, the length. If we hit the apply, hit OK, let's shift back to this client so we can see that is the same. So for the comparison, we can see using this string, the start address and the length, that is more easier. All the quality shows good, so that means the connection between this Kepware and the actual controller, that's correct. So that is for today. In this video, we introduced how we can use the KEPServerEX software build up the channel, the communication between the i7-1200 controller. In next video, I will introduce how we can set up the DDE client channel and advanced tags that allows we build up the bridge, transfer the signal between the DDE channel and the PLC channel. And after that, we will use the DDE channel to send the data to Excel, allow Excel to read the data from the PLC. So see you in next video. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe. See you in next video.